Okay, so what I intend to do in this video is just show an issue that you can have when carrying out AC impedance measurements on battery systems. There are a couple of methods of connecting the cells together that I have come across that I hope to be able to emulate with this little setup I've got here. So with this setup, we've got a 12 volt cell here that's just wired onto this block. These two bolts here are representative of the terminals on the cell that you would then put a connection strap from this one to the next cell and from this one to the previous cell. So I'm going to measure the impedance on this as it sits here, and what I'm looking at is the actual impedance effectively of the cell, which I'll take from these two strips. Set the voltage up, and we're in 300 milliohms. Okay, so we've got 79.2 milliohms effectively acting as the impedance of this particular cell. The bolts here, I'm just going to torque them down. I'm going to use 15 Newton meters. So battery terminals I'm used to anywhere from 10 up to 30 Newton meters. We're in WIMP mode tonight, so we'll stick to 15 Newton meters, make it easy for myself. I don't know how you'll tell. It's very hard to tell that this ratchet is actually tripping over. Okay, so they're both tightened down, and what I need to do now is go from the metal bolts and have a look at what the impedance is now. Oops, we don't get rid of you. Okay, so we're now 79.4. So with this connection methodology, I have actually added 0.2 of a milliohm, which is quite good. And normal steel bolts, I'll show you a picture of the kind of cell straps that you have. When you have this kind of connection, you then have an insulation cap that goes over the top of this, and you have a test point, but your test point goes straight onto this bolt effectively, so you don't really affect the impedance value of the cell that you are measuring. So I'm just going to take one of these bolts out, because the other connection methodology that I have come across is to use an insulated connection. And with this method you get an insulated strap and you get a bolt with a pre-insulated head on it, similar to this one here. And there are a couple of problems with this type of connection methodology with regards to measuring AC impedance. So this is a brand new bolt. You can see the Loctite is still in place around there. If I try and measure the impedance of this bolt, I will struggle to get a reading because the test points are made, so I can't actually get a read in there. Pressing relatively hard. In fact, you can see how hard I'm pressing, because that doesn't come off now. And this isn't peculiar to the Hioki probes. I will set up the applant meter and I'll just give you a look at that and show you that the applant has exactly the same issue with this type of connection bolt. Okay, so we just got the applant meter sat there, and these are the probes off this same concentric style probe that the Hioki uses, and we'll try and get a reading from this one as well if we can hold it. And you can see no chance of getting a reading in there. In fact, these are a little bit bigger, so this doesn't go in at all on this. Oh, you can see it goes in there. See, it hardly goes in at all on this one, and you can't get a reading. So the first thing you have to do is drill out the heads of these bolts. A slightly bigger drill. And it doesn't take much to do because it's only plastic. If you clean him out, we should then hopefully be able to get a reading. And there you can see I can now get a reading. For a straight bolt, that's obviously quite a high reading, 93 milliohms. And the morning, you see it's bouncing around a little bit. You can see once I've drilled the hole out, I can get that reading. We'll chuck him to one side and we'll go back to the Hioki. So the Hioki there, and you can see 124 on that particular one. But you can see I can now get a reading. Try him again. 124. Now, the reason why you're getting such a high reading on these bolts is because of the second issue that you have with this type of bolt. And here you see I have one that's cut the head off. And you see I've got my steel bolt there, but in here is a lead plug that acts as the test point. So when you put your multimeter probe in, you're putting it into a relatively soft lead as opposed to the hardened steel, which makes it a bit better connection. Problem is you have a dissimilar metal connection there, which will produce a higher resistance reading. You also have, over time, these little lead balls move around and you can change the impedance between the ball and the top of the bolt head, and that affects your AC impedance measurement. And I can demo that with some of these bolts I've got here now. So we'll take the red one now. These bolts have a shoulder on them as well. That's because of the way the strapping works. So to overcome that, I'm just putting a steel washer over the top to spread the load to the head a little bit better. And we'll put this bolt in here. So this will be the red one. It's my socket. Put him up. You can see we're still on the 15 Newton meter mark there. And we'll torque him down. Again, I don't know how well you'll see how well the handle operates. That's just clicked over then. So that's 15. And we'll take another measurement. Okay, so 83.7 on that particular one. What you also notice is 12.92 on the volts there. So we'll drop him back out. And we'll use another bolt. So that was my red one. We'll use our blue one this time. Torque him down. That torqued. Try another measurement again. 83.7, 12.92 volts. So we've got 12.92 volts again, but this particular one has gone over 310 ohms, so we'll up at the scale. Okay, so that's 653 milliohms, but we've still got 12.92 volts. Drop him out. And we'll go for the grey-headed bolt. And this is just the selection of bolts that I have. It doesn't actually matter, you can still get the same variation just with all bolts with a black head on them or a grey head, whatever you actually have. It's the erratic nature that's the problem. That just torqued. So we'll go again. $511 this time. But we still have our 12.92 volts. So the voltage stays consistent across all the measurements, but that's when I'm actually doing this kind of test, that's secondary to the actual resistance reading, which is the one I'm actually after. But you can see it's just completely all over the place. And if looking back, our original cell was 79.2 milliohms. When we look at AC impedance measurements, we're actually looking to see when the resistance value doubles, we would, as talked, we would say the cell has reached the end of its life. And obviously 79.2 milliohms, we're now on 511 milliohms here, so that's way over. We'd be thinking we've got an issue with that cell. In actual fact, all it is this connection bolt. So that one's 410 milliohms, that was the black one. So you can see that's quite a variation. I put a plot and a table up at the end of all these different resistance and just show you just how erratic the measurements actually are. Let's just try the on the black one again. I'll just press a little bit harder this time. 467 this time, and it was 410 last time. So you see, even with the same bolt, I can't get. Now, ooh, the AC doesn't like that, does it? Yeah, and you see this is what happens to it. That lead ball is moving around and it's creating me a bad connection now. So you just can't get a stable reading with this kind of bolt and tester. Let's just stick the stainless one back in. And this should drop back down to the original 79.4 or thereabouts. Or this video has just become a complete mess. So the main reason why I'm using insulated tools is I don't have a torque wrench that goes this low other than an insulated one. And obviously if I did short across there I would be shorting out that battery. So that just torqued. Get rid of him and go back. 0.79. We can drop back down to the ranges this time now. That's 300 milliohms, isn't it? 78.7 this time. That's 0.7 milliohm difference. So again, it's changed a little bit, probably because of the way I've torqued it down. But you wouldn't be repeatedly undoing the bolts. Once you've set the installation up, they stay like that then, unless you have to change a cell out. But it's the erratic nature of these kind of bolts with regards to AC impedance measurements that I wanted to show. So whilst I was carrying out this discharge test on this nickel metal halide battery I've got here, I did a couple of more tests on these insulated bolts. I've got 2 in my little test block now, and the previous reading I did on these was 876 milliohms. I'll stick a picture up of that, and I wondered what happened if I actually drilled out the lead ball completely. So there's my little swarf there from drilling out the lead ball. See my magnet here, it doesn't pick up to that at all. If I put it on a bolt, then there. So you know the bolt is still inside, but this is lead. It's non-ferrous, so it doesn't react to the magnet. And I just wondered what happened if I tried taking a reading now. So we are set up. Let's change it to 60. 30 milliohms, so we'll go up. And you see the probe's going deeper now. So we've got a 12.92, and we've got 80.9 milliohms, which is substantially better from our 79. It's only up from our 79, isn't it? Let's see if we've got consistency. 79.6. 9.4, so pretty good now. It's consistent now. Yeah. There's always one reading that's slightly out, isn't there? Yeah, it depends perhaps where you have the actual probes, whether I needed to drill them out a little bit more, I don't know, but it's one resolution potentially to it. It's a lot better, 2 or 3 milliohms up from what it was when you're just on the battery cell itself. So yeah, 78.5. So it's perhaps one solution if you do have this issue. Probably a painstaking job to drill them all out though. So there you have it. As I said, I'll stick the results up at the end and a little table and a plot so you can peruse them for yourself. But if you are having issues with taking AC measurements on lead acid cells, check what kind of connection box that you've got, and if they have these little lead test points in them, that could well be your issue. Okay, that's it for this video. Thanks for watching. Hope you found it useful, and I'll see you again in another video.